In the case of hydrogen and ions that have only one electron, so we're just dealing with systems here that have only a nucleus and an electron, it turns out that the energy of the electron will depend only on the quantum number n. And the energy is given by this expression right here, negative r sub h times z over n squared, where r sub h, called the Rydberg constant, has a value of 13.6 electron volts, or 2.18 times 10 to the negative 18 joules. Notice that the energy here is negative. What does this negative energy mean? It simply means that you're looking at an energy level that's lower compared to the case where the electron is at infinite distance from the nucleus. In other words, if you want to remove the electron from the atom, you have to provide it with energy in order for the electron to be able to move away, as far away from the nucleus as possible. Okay? So energy is just a matter of convention. We define the situation where if the electron is at infinite distance from the nucleus, we define that to be the zero energy, zero potential energy, in fact. Okay? Now, the ionization energy, okay, is the minimum energy you need to remove an electron. So if you want to go from whatever the energy is of the electron to energy equals zero, remember, energy equals zero means the electron is able to move away, as far away from the nucleus as possible. That's your ionization energy. So the ionization energy will just be the negative of the energy of the orbital, of the electron in that particular orbital. Now, what if you provide more than that? Well, if you provide more than that, whatever extra energy you have, you provide, let's say, from a photon, becomes kinetic energy of the electron. So this is similar to the photoelectric effect phenomenon we talked about earlier. So you can think of the ionization energy as the binding energy of the electron to the atom. Okay? So, just an example. In a hydrogen atom, which orbital describes an electron with higher energy, 3s or 3p? Well, what's the energy of an electron? It's just negative r sub h times z over n squared. Right? So hydrogen atom, you're comparing the same thing, right? Z equals 1 proton in the nucleus. But 3s, for a 3s, n equals 3. For a 3p, n is also equal to 3. So the answer is the same. It takes the same amount of energy to remove an electron from a 3s orbital as it does from a 3p orbital of a hydrogen atom. Okay? Depends only on n. And in 3s and 3p, you have the same n. Here's another example. What's the minimum energy you need to remove an electron from the 2s orbital of hydrogen? Well, let's see. E sub n is negative r sub h z over n squared. So that's negative 13.6 electron volts times 1 over, 2s means n equals 2, right? So you're going to plug in 2 there. So 2 squared. So that's negative 13.6 divided by 4. Negative 3.4. So this is going to be negative 3.4 electron volts. Okay? That's the energy of your 2s orbital. That means, okay, so if this is the energy of the 2s orbital, this is negative 3.4 electron volts. Okay? Zeros over here. You need at least 3.4 electron volts to allow, so this is your energy scale, your electron to move away from the nucleus, to be removed from the atom. And that follow-up to this question is, if this electron were to encounter a photon that has an energy of 5 electron volts, what would be its kinetic energy once it leaves the atom? Well, it's going to absorb 5 electron volts, right? So 5 electron volts. 3.4 electron volts is the ticket out of the atom. Whatever excess you have left, what's the difference between 5 and 3.4? It's 1.6 electron volts. That becomes the kinetic energy of the electron. as it leaves the atom. Okay? All right. From which of these would it be hardest to remove an electron? 1s of H, 1s of He plus, or 2s of He plus? Okay, let's just do, you really don't need to calculate it. Let's just compare H versus He plus. Remember your formula, E equals negative R sub H Z over N squared, right? The larger the Z, okay, that means the more negative your energy is harder to remove. Everything else being the same. Think of it this way, the larger the Z, the more protons you have in the nucleus, the more protons are pulling that electron in. So everything else being the same, a higher Z would make it harder to remove an electron. Okay, so let's compare helium. You have 1s hydrogen, 1s versus helium plus. Z here is equal to 1, Z here is equal to 2. So it's harder from helium plus, right? So answer can be A. Now let's compare 1s versus 2s. Well, what does 1s versus 2s do? The larger the n, okay, so 1s, n equals 1, right? For a 2s, n equals 2. The larger the n, the smaller the energy, the less negative the energy. So 1s would be harder to remove. Everything being the same, it would be harder to remove an electron from the 1s orbital than it is from a 2s orbital. So the correct answer here is, it's not this one, correct answer is B.